All right, so for this, I am going to go through all the questions, maybe not all the word problems. The exceeding, that's supposed to be you guys being able to apply what we've learned in different ways. I will go through just at least a couple of the word problems, though, just so you understand like that you're following the instructions and kind of go through it a little bit with you with that, but I might not go through all the word problems. We'll see. Um, but for the rest, I'm going to go through them all. It's going to be kind of quick as I go through them because at this point, it's not teaching you it, it's showing you how to solve these questions. So if you guys don't get it right and you can't identify your answer, or identify how to answer it on your own, then refer to this video. And I'm just going to go through how to solve it and how to show your work as well. And if you still don't understand, then make sure you're reaching out for help and seeing me before our assessment on Thursday. All right. So for this first one, I see that this is a positive 7. So this is being added. We can rewrite this if we wanted to as negative x over 3 plus 7. I could rearrange them if I wanted to because addition subtraction can go in any order. So this is a positive 7. So then to move it to the other side and to zero it out on this side, I need to subtract 7. So it becomes negative x over 3 is equal to negative 9. And now fraction is also we can think of as division. So I need to multiply each side by negative 3. And now when I multiply each side by negative 3, I get x is equal to a positive 27. All right. And I know that I'm multiplying it by negative because this is minus x over 3. So on your last assessment, a lot of you were dropping that minus sign as you move to the next step. So make sure you're understanding it's a negative. So I can do it in 2 steps if I wanted to get rid of the division of 3 first. But since I know it's a negative, I'm going to have to multiply or divide by negative anyway at some point. So that's why I'm just multiplying each side by that negative 3. All right, so now for this next one, number 2, 9x plus 34 is equal to negative 128. So I know I need to get rid of my addition first. I'm going to subtract 34 from both sides. So now I get 9x is equal to negative 162. And then to solve for x, it's being multiplied. So I need to divide each side by that 9. And x is then equal to negative 1, 8. So negative 18. All right, so now for this next one, there's a couple ways you can solve this. So if you do it a different way than what I'm showing in this video, you can still be correct. But as I talked about it with you in class, is that sometimes not everything is going to be divisible by the number that's being multiplied out front. So I always just teach it to simplify by distribution first and then combining like terms if needed. But there's other ways you can solve this. But remember, parentheses mean multiply. So everything in this parentheses is being multiplied by 8. So I need to distribute it in. So I get 16x minus 24 is equal to 40. And now it's just back to a very basic equation that we have. So I'll add 24 to both sides. So now I get 16x is equal to 64. And then I'm going to go ahead and divide each side by 16 to isolate that variable x. So x is then equal to 4. All right, so for this next one, everything in this numerator, we can treat it as a parentheses because it's a grouping. We would need to do everything in that numerator first if we knew what x was actually equal to. So I do need to get rid of this division of 4 first. So remember, fraction we can think of as division. So I'm going to multiply each side by 4. And when I multiply this side by 4, it just cancels out with this here. And I'm left with 7x minus 5 because if I'm multiplying everything by 4, then eventually I'm going to divide it by 4, and it's just going to end up canceling it out. So I'm left with everything that's in my numerator. So 7x minus 5 is equal to 44. And now back to our basic equations. I'm going to add 5 to get rid of this first. So 7x is equal to 49. And then I'm going to divide each side by 7. And x is then equal to 7. All right, so for this number 5, once again, the first thing I'm going to do, I see parentheses, so I'm going to distribute this in. So I get 12d minus 8 is equal to 8d plus 8. And then I'm going to go ahead and subtract over. I'm going to move all my d's to the left, so I'm going to subtract my 8d. So this way I'm getting my variables all on one side, and 12d minus 8d is 4d. So 4d minus 8 is equal to 8. And now I need to isolate my variable just like I have been. So I'm going to add 8 to start getting the variable all by itself. So 4d is then equal to 16. And our last step is to divide by 4 to isolate that variable and solve for one of them. So d is then equal to 4. All right, so all those other questions before were approaching proficiency. So those are ones I do expect you're all able to do without really much challenge. If you are struggling with those, then please make sure you're scheduling time to see me. And these are the questions that you will get mastery for. So for all of these, every single question that you are answering, the steps I told you to follow is first, look to simplify. And when you're looking to simplify, there's two things that we're looking to do there. First, can we distribute or multiply? And we know that what we're looking for there is parentheses. If I see parentheses, it's telling me I need to multiply. And then after, if there's something that we can multiply, we look to combine our like terms. And once we do this, it then just brings it all back to the same kind of equation pretty much every single time, where then we will just have maybe a variable on both sides where we have to move them, but it simplifies it all to make them all look the same. So this is the very first thing that we do need to look for, or that I suggest you look for when you're solving these. So when we get to these harder questions, it's just following the same steps. So I see parentheses, that means I'm going to multiply. So the first thing I'm going to do is multiply. So AF minus 40 is equal to AF plus 40. Something should start to jump out at you about this particular question. Once we do this, we look for, can we combine like terms? And there's nothing I can. So now I look to isolate my variable. And to do that, I need to move my variables to one side of the equation. So I'm going to move my variables to the left. So I'm going to subtract AF to move this AF to the left-hand side. But when I do that, both of them cancel out. So now I'm left with the equation, or the problem is negative 40 is equal to 40. Now, does that make sense? No, this is a false statement. And when we get a false statement, we know that that means no solution. So remember, when you're showing me your work for this, I need to know that you're not just guessing. So you need to get it to here to where you show me it's false. Or if you stopped here and you could identify that when we had that blue equation here, that means it's going to be no solution, explain to me in words how you know. All right. I can't just assume with things. So I need to make sure that you're not just guessing. And I want you to get in a habit of showing your work all the way through. All right, so this problem here, I see that we have parentheses, so I'm going to distribute. So it's negative 2, so I'm going to be multiplying a negative 2 in there. So it's 3x minus 2x plus 4, because a negative times a negative is positive. After we distribute, we are now going to look, can I combine any like terms? Yes. I have 3x minus 2x on the same side of the equation. And remember, if you're having trouble with differentiating between when we are just combining what they are or using inverse operations to move, draw a line down your equation. And anytime we're staying on the same side of that line, we're just combining them as they are. And 3x minus 2x is x. So now I have x plus 4 is equal to 5x plus 4. So now I say, okay, I have variables on both sides. So I'm going to move my variables to the left-hand side. So I'm going to subtract 5x. And now since I'm going to the other side of the line, I see I do need that inverse operation. So negative 4x plus 4 is equal to 4. And then I'm going to move my constant to the other side by subtracting 4. So now I have negative 4x is equal to 0. And this is where some of you guys were going wrong in the last test, is you were saying either no solution or infinitely many. But here we still have a variable. The only time that we get one of those special cases is when the variable disappears. If we have a variable, we have an answer. So from here, I'm going to divide each side by negative 4, and 0 divided by any number is 0. So x is then equal to 0. All right, so I put these ones next to each other so you can see the difference from when one is a special case versus one is 0. And the next one is another special case as well. All right, so first thing we do is we look, I see the parentheses, so I'm going to distribute this 8 in. So I get 14 plus 56x minus 22 is equal to 56x minus 8. And then over here, I see I have like terms of 14 and minus 22. So 56x minus 8 is equal to 56x minus 8. Once again, it should maybe jump out at you now that we know that this is going to be all real. If you stop here, write it out in words how you know. Or I'm going to move this to the left. So by doing that, I will subtract 56x from both sides. And when I do that, it eliminates my variable. And now, since I have no variable, I know it's special. So it's going to be either no solution or infinitely many or all real numbers. And since this is a true statement, I know then that my final answer is going to be all real numbers. So you can just write the symbol, or you can write it out if you would like. And if you wrote infinitely many, you get credit for that as well. All right, I'm going to just erase this though as we move on to number 9, so that way I have space for that. All right, so for number 9, once again, I see parentheses, so I know I'm going to have to distribute. So I'll distribute that in. So 4 plus 3x minus 20, because negative 2 times 10, minus 8x, which is negative 2 times 4x, is equal to negative 6x minus 2. I know now that I'm going to look to combine like terms. So since all of these are on my same side of that line, I don't need to do inverse operations. So 3x minus 8x is minus 5x, and 4 minus 20 is minus 16, is then equal to negative 6x minus 2. Now I'm going to move my variables to one side. So by doing that, I'm going to add 6x, so that way it zeroes it out. So negative 5x plus 6x is x, minus 16 is equal to negative 2. And my last step then is going to move my constant to the other side by adding it. So then x is then equal to 14. All right, so before we get into number 10, this is one that I will kind of teach a little bit. You guys can just, because you're allowed to use a calculator, you can just add them like they're regular fractions till you get to your answer. But I'm going to show you how to get rid of your fractions. If I give you a statement that 1 plus 2 is equal to 3, everyone agrees that that is a true statement. If I multiply every single number by the same thing, so I'm just going to pick 4. If I multiply every single term by that 4, so this then becomes 4 plus 8 is equal to 12, which is still a true statement. If now instead of 4, I multiply it by 10, but as long as I multiply all of them, 10 plus 20 is equal to 30. That is still a true statement. But what happens when I only multiply one or two of the numbers? So let's say I'll multiply by 3, and I'm only going to multiply by the first 2. So now I get 3 plus 6. Well, does that equal 3? No. So you see, as long as if we're consistent and multiply every term by that number, it still holds to a true statement. So that's one of the ways that we can get rid of these fractions. And in math, a lot of things is manipulation. So if a problem is written in a way that we don't like, we can try to rewrite it in a way that makes more sense to us and things that we've seen before. And as long as if we're being consistent and applying rules properly, we can do that. So in math, there's going to be a lot of things like in the future when you guys get into higher level maths, to help you to factor and to solve some questions, you're going to add 0 to your problem, but you're going to actually rewrite it as like 5 plus 5 minus 5. And by doing that, it gives us numbers that we will be able to use in our problem, but ultimately we're not changing the value of anything because 5 minus 5 is 0. So we're keeping it the same value, but we're manipulating. So in math, especially once you guys start to get used to solving, sometimes in the future, you're going to have to manipulate your problems. And this is one of the ways we can do this. So what we do is we find our least common denominator. So if I were to add all these fractions together, what would the denominator need to be? And I have 8, 4, and 16. Well, since 8 and 4 both go into 16, 16 would be our least common denominator or least common multiple. So what I do then is I multiply. I'm going to cross out this 10. I multiply everything by 16. So when I multiply this first one by 16, it's going to be 16 times 7x over 8. And since 8 goes into 16 twice, I'm going to multiply that 7x by 2, so I get 14x. Then I'm going to distribute the 16 into this next one. So then it's 3 times 16 over 4. 4 goes into 16 4 times, so it's left with 3 times 4, or minus 12. And then I'm going to distribute to this next one here. So once again, it's going to be 16 times 5x over 16. Well, they're going to cancel each other out completely. So now I'm left with minus 5x. And then the last one I will distribute here. So it'll be 16 times 3 over 8. 8 goes into 16 twice. 2 times 3 is 6. So it's going to be equal to 6. Now, these are the same problem in the sense that because we were consistent and multiplied everything by 16, we just rewrote it. But it's still a true statement. So now from here, I got rid of all my fractions and I can solve this like a regular problem. I have 14x and minus 5x, so it's going to be 9x minus 12 is equal to 6. I then am going to add the 12 to both sides. So 9x is then equal to 18. And then I'm going to divide each side by 9. And x is equal to 2. So we can manipulate our problems and get rid of the fractions if we would like to. It's up to you on how you want to solve this, because since you're allowed to use a calculator, there's really not that hard if you just kept it in fraction form. But I'm all about teaching you how to get rid of these fractions and how to manipulate your problems at times. So when we can, I'll show you some of the things that we can do. All right, so now we're going to move on to the exceeding problems. All right, so as we talked about in class, if I give you two fractions, let's just say 2 and 6, and I give you another one, and let's say 3 and 9, you should be able to identify that these are in fact equal to each other, but we showed that if we're testing if they're equal, we can multiply one numerator with the opposite denominator, and 2 times 9 is 18, and the other numerator with the other denominator, and 6 times 3 is also 18. And if those two multiples are equal to each other, then I know the fractions are equal to each other. And we know that both of these can reduce to 1/3. So you should have hopefully been able to identify that before. So one of the things, though, is if I, instead of asking if they're equal, which is what we did in this problem, if I tell you they're equal, so I say that 2 6 is equal to 3 9, we know 100% their cross products are going to be equal. So then if I remove this 3 and say, well, I don't know what that numerator is, we know that since they're equal, that their cross products are going to be equal. So I can rewrite this as 6 times x is equal to 2 times 9, or 6x is equal to 18, or x is equal to 3, which we knew. So when we're told that two fractions are equal, we can apply this cross product in order to solve. So here, since I know that these two fractions are equal, I'm going to cross multiply. So 6. Where this problem gets more challenging, though, is we need to remember to distribute that 6 into everything. And the same thing with this 3. So it's going to be equal to 3 times 9 minus x. So write it in parentheses so you remind yourself that both are being multiplied by 6. So 72 minus 6x is equal to 27 minus 3x. And now I'm going to go ahead and move my x to the left-hand side. So I'll add 3x, add 3x. So now I get 72 minus 3x is equal to 27. All right, I just was erasing that so that way we have more room. So now from here I have 72 minus 3x is equal to 27. So now I'm going to minus the 72 since it's a positive. So minus 72, so just like the first question we did. So minus 3x is equal to negative 45. So now I'll divide each side by negative 3. So x is then equal to 15. All right, so for this one, there's a few different ways you can go about doing it, but I'm going to practice this, what we just learned. All of these technically have a fraction of 1 or a denominator of 1. We can all write them as a fraction. So what I'm going to do then is I'm going to multiply everything by this 7 to get rid of that fraction 7. When I multiply the first one, it's going to cancel this out. So I'm just left with 6 times x plus 10. And then I just need to remember to multiply to everything else. So plus 14. And here, since they're already being multiplied, I can just multiply the 2 and the 7 because it's 7 times 2 times x minus 1. So from here, I don't need to multiply both the 2 and the x minus 1 by 7 because I'd be multiplying it one too many times, because in multiplying 2 times 3 times 4, well, we would do 2 times 3 is 6, 6 times 4 is 24. We wouldn't do 2 times 3, which is 6, and 2 times 4, which is 8, and then multiply. When we multiply, we all multiply them once. So this would then become 14 times x minus 1. So now I'm going to go ahead and distribute the 6 in. So 6x plus 60 plus 14 is equal to 14x minus 14. I'm going to combine my like terms. So 6x plus 74 is equal to 14x minus 14. All right, so then from here, we're going to continue up here. I'm going to subtract the 14x from both sides, though. So this will then give me negative 8x plus 74 is equal to negative 14. I am then going to subtract the 74 from both sides. So negative 8x is equal to negative 88. And then the last part will be dividing by negative 8. So x is then equal to 11. All right, so this next one, there's multiplying for every single one. So I'm going to distribute this 3 in. So I get 15x plus 4. Here I'm subtracting everything. So as long as if you remember that this 5x needs to be subtracted and this minus 6 needs to be subtracted, you can just apply that. Or what we can do to help us is think of this as a negative 1. And then we can just multiply everything by negative 1. And it'll give us the same effect. So minus 5x plus 6, because here it's positive 5x and we're subtracting it. Here it's minus 6 and negative 6 turns a positive. I just think I see students make less errors when they think of that and treat that as a 1 and distribute that in. Now this is equal to 6 times 3x, which is 18x, and 6 times 4, so plus 24, and minus 2 times 8x is minus 16x, and minus 6. So now from here, I'm going to just draw this line. So on here, I have like terms of 15x minus 5x, which is 10x. And here I have 4 plus 6, which is plus 10. Here I have 18x minus 6x, which is then going to give me 2x. And here I have 24 minus 6, which is then plus 18. And then the last, I'm sorry, I made a mistake here. This should have been plus 12. 3 times 4 is 12. So then this would have been 6 plus 12 is going to give me 18. So I'm going to move my variable to the left-hand side. So I'll subtract 2x from both sides. So 8x plus 18 is equal to 18. I'll subtract 18 now from both sides, and that's going to actually cancel both of them out. So 8x is equal to 0. Divide each side by 8. So x is equal to 0. All right, so that's all the solving equations ones. Now we're going to go ahead and move on to the word problems. I'm only going to go through maybe 1 or 2 of these. All right, so for this, there's 3 things you must do. You must first translate it into an equation. So if I don't see an equation written, you can't get credit for it. Except for number 18, I tell you don't have to do an equation for that one. But for these ones, you must do an equation. And if you can't, you won't be able to get full credit. Then you need to define your variable and then solve. So from here, I say 5 less than twice a number is 17. So I'm just going to create a variable I want, and I'm going to say n because we're talking about a number. It could be any letter we want. And I need to say what that represents, and that's how we're defining our variable. What does that variable mean? So n represents the unknown number. I don't know what that number is. And when you see me write this equation, you're going to see this variable n in it. So remember, treat me like I don't know anything, like I'm an idiot. So tell me what that means. So now we're going to go ahead and translate this into an equation. 5 less than twice a number. Well, if I say 5 less than 8, what is 5 less than 8 equal to? Well, we're saying 5 less than 8. So that means we're actually doing 8 minus 5, which is 3. So when we see this less than, and we're not talking about inequality, but it's an equation. These ones we actually need to reverse the order. So here, 5 less than twice a number. Well, it's going to be minus 5. Twice a number, since I said n is representing that number, twice that is just 2 times that. And is we know is equal. So this is the equation we're setting up. And then we just solve it like we normally would. So 2n is then equal to 22. Divide by 2. So n is equal to 11. So the unknown number is 11. And we can check our work. 2 times 11 is 22. 5 less than that is 17. All right, and then this is the last one I'm going to go through. And then you can apply this to the others, but just making sure that you understand the 3 things I'm looking for these problems. So for here, a video game store allows customers to rent games for $4.75 each. Customers can also buy membership. That's $54 annually. And then anytime you rent a game will only be $2.50. How many video games would a customer have to rent in a year in order for the 2 options to be equal? So we have 2 things. We have membership and we have non-membership. So in a non-membership, they're going to pay $4.75 for every video game that they rent. So I'm going to write $4.75. And if we rent 1 video game, it's $4.75. If we rent 2, it's going to be $9.50, and 3, and so on. And we could think about it as we're adding that every single time, and repeated addition we know is multiplying. So I'm going to represent the non-members as $4.75 times V. So now I wrote this variable in. So what does this variable represent? So V represents the number of video games rented. So if you rent 1 video game, you're paying $4.75. So now I'm going to look at the membership one. Well, the membership, you're paying $54 no matter how many games you rent. So $54 right up front. And then every time you rent a video game, you're going to also pay $2.50. So it's going to be adding to that cost. And now it's going to be $2.50 times V. You don't have to write that 0. You can just write 2.5 if you want. But for every single video game you rent, you're paying $2.50. And then it's going to be $54 in total. So it says, how many games would it be for the 2 options to be equal? Well, just think about how we can show that these are equal, putting an equal sign in between them. So now from here, I will write this off to the side. So now we have the equation of 4.75V is equal to 2.5V plus 54. And now we just need to go ahead and solve for that V. So we'll subtract 2.5V from both sides. So now we get 2.25V is equal to 54. And then we'll divide each side by that 2.25. And V is then equal to 24. So that means that you would have to rent 24 video games for those two options to be equal in value. All right, that is it for this video. If you need any help, just make sure you're reaching out.